Hello and welcome in this video. Today I have brought an interesting topic related to electricity. Today we are going to learn about electric shock and safety measures. Today in this video, in this time, we are going to learn how do we get an electric shock and what are the safety measures of not getting an electric shock and what are the electrical safety system. Okay, but for this you need to completely watch this video. If you leave this video in the middle one, okay, middle point of time, then the knowledge will be incomplete and you may not know anything regarding this. Okay, so it is one of my interesting topic. Okay, I really want to make a video regarding this topic, electric shock and safety measures. How this happens. Okay, what type of electric shock we get. Okay, what are the types of electric shock we are going to get, and what are the safety measures we need to follow in order to be completely safe from electric shock. It helps to save a life of a person. Okay, if you know about this video, you can convey this message to other the near and dear one, okay, to prevent them from this type of electric shock. So now I want to move towards this video, but before learning this video, we need to know about some fact. Okay, we need to know about a conductor and insulator, electrical conductor and electrical insulator. Okay, what do you mean by electrical conductor? Those conductor, electrical conductor means those device which helps to conduct electricity. Suppose wires, suppose metals. These are the example of electrical conductor. Okay, electric wire helps to conduct electricity from one point to another, so that is called a electrical conductor. Metal is also electrical conductor. Not only this much, human body is also electrical conductor. Okay, suppose if a person is here, okay, if he touches a wire on this side, okay, containing electric current, and if he touches the other wire, okay, then the current travels from the wire to the person body and it travels to the other wire. Okay, so that's why this is also a conductor. So what do you mean by insulator? Conductor and insulator are just opposite to each other. Conductor helps to conduct electrical current, okay, electron. Insulator do not helps to conduct the electricity or electron. Suppose example of insulator is wood. Okay, wooden piece, wood, that is also a dry wood. Okay, not a wet one. Okay, completely it should be dry. Or another one is a example of rubber. These are the very good conductor or insulator. Okay, these are the very good conductor and these are the very good insulator. Now we need to know about something more regarding this topic. Okay, that is the type of electrical wire. Okay, before learning this thing we cannot directly know about the topic, so that's why we are going to learn about the type of electrical wire. Okay, in our house we have a different type of electrical wire. One is a red color wire that we call it as a live wire. Another one is a black color wire, we call it as a neutral wire. Okay, that is of 0 volt. Actually in our house we get a alternating current of 220 volt. Okay, and we have a neutral wire of 0 volt. Okay, this will be supplied from the electricity office, and this live wire contains an electron. Okay, and this neutral wire do not contain any electron. Now what is the working mechanism of this two wires? Okay, suppose if I connect here one electric bulb. Okay, if a electric bulb is here, okay, if this is a electric bulb, if a red wire is connected to one side of electric bulb and the black wire is connected to the other side of electrical wire bulb, then what happens? Electron flows from live wire to the bulb. Okay, and inside the bulb there is the connection with some type of metal substance. We call it as a tungsten metal. So this element, okay, this is a type of element. Now what happens? Electron flows from here and it returns back through the neutral wire. So this is the working mechanism. That means electron is coming from live wire and going through the neutral wire. That means it gives a path to for an electron to flow outside, okay, from the electrical appliances. So this is the simply connection. Now live wire contain an electron and neutral wire do not contain an electron. Okay, now this is the working mechanism electrical bulb. Now how this electrical bulb operates, due to the complete cycle of electron. Suppose electron is coming and it is going, that is, it is making a complete cycle, otherwise this bulb do not glows. If you break a neutral wire here, then what happen, this bulb do not glow because the cycle of electrical current stops in the middle. So now suppose a electrical person is here, okay, human body is here. Human body is a good conductor of electricity, as I told you. Now this is the hand of human being. So what happen if the human being touch this red color wire, then what happen, electron also flows to the human body. Okay, now it requires a path to flow outside from here. Okay, it requires a path to flow outside from the human body. Okay, now where does it go? If a human body, hand or head or any kind of leg, okay, if it is touching to the ground directly, okay, ground, okay, if it is touching to the ground, then what even all the electron flows from higher potential, that means 220 volt, to the lower potential, that is ground, which we call it as a 0 volt also. Okay, now what even electron flows from live wire to the human body and it flows to the ground. That means there is a complete cycle. Okay, it is going to the lower potential from here. Here also it was coming from higher potential and going to the lower potential. This one is also lower potential. So that's why this is the type of electric shock. Okay, actually this is the cause of electric shock for a human body. Now, there may be a question, if what even if a human body is standing in an insulator? Okay, suppose he or she is standing in a wooden piece or in a rubber, okay, and no any other body parts is connected with the ground, and one hand is connected with the live wire. So at this case, the electron obviously flow to the human body, but it do not get a path to go outside from the human body. So as a result, this human body do not get a electric shock. But okay, there is a but. If another his or her friend comes, okay, okay, if another his or her friend comes near to him, and if he or she touches to him, then what even, electrical current is coming from here to the human body, and although it is not connected with the ground, it gets supplied to the this person. Okay, and if this person is connected to ground, then what happen, the human body electricity flows from here to this body and to this one, and if he or she is connected to the ground, then this two person gets a electric shock at the same time. Okay, but what even this, if this person again stands in the insulating wire, then what even, electric current flows from here to here, but the circuit is not complete. So that's why this person do not get a electric shock. Okay, I hope you have understood about this thing. Okay, how a human body gets a electric shock. Now there may be another question about a human body. Okay, suppose this is a human being, if he or she touches this wire, then what happen, electricity comes from here. Okay, electron flows from here, if it goes to the electric bulb, and the electron returns from this path. As soon as the electron comes to the in contact with the neutral, okay, then what happen, this neutral wire have a minimum resistance. Okay, resistance means the property to stop the flowing of current. Suppose electron is flowing from here, okay, electron is coming, it is it have a minimum resistance. 0 volt means very very low resistance to stop this electric current, but human body have a high resistance in comparison to this wire. So as a result, electric current always go to the path where the electrical resistance is very low. Okay, I have made a video regarding electrical resistance. I'll put that in the I button. Okay, later on you can watch, but the thing is same. If he or she touches this wire, then electron although comes here, okay, through the complete cycle from electric bulb, not from the human body, then what happen, then electron goes to the electric power station, or directly it will be also connected with the ground. Okay, this neutral is a common point. Okay, finally it will be connected with the ground. Okay, same like this one, a human body. So now what happen, if he or she touches this wire, then what happen, electron never flows to the human body. Okay, it flows to the neutral wire and it finally ends with the ground. Okay, so this is a earthing. This is a earthing. Okay, there are three types of wire. Earthing we'll do in our house. Okay, I have made a detailed video about this earthing. I'll keep it in that I button. Okay, I'll talk about this later. We all know that earthing is done in our house. Okay, and it is for the safety purpose, and its color code is green color. Okay, neutral wire is always given a black color. Live wire is given a red color. Okay, that is a symbol of danger also. So that's why if a human being touches this live wire, he or she gets a electrical shock. Okay, even though if a human being touches a neutral wire with a bare foot without any insulator, then he or she do not get an electric shock, because human body tries to oppose the flow of electron. So that's why electron flows through this wire, it never flows to the human body. So that's why this is the thing to be known. Now another, we need to know about the causes of electric shock. How do we get an electric shock? Direct contact with the live wire or a faulty neutral wire. Okay, sometimes I have already talked about this. What do you mean by direct contact with the live wire or a faulty neutral wire? Okay, I'm dealing with this point now. Suppose human being is directly in contact with the live wire, or human being is directly contact with the neutral wire. Okay, but I'm using here word faulty. Okay, if this neutral wire is broken, then what happens? Electron flows from here to the ball, and it flows to the neutral wire, but it cannot go to the source. Okay, it cannot go finally to the ground. So that's why if here is broken, if any wire is broken, then it means that that is a higher resistance. Electron cannot flow. Okay, because resistance, okay, this word we need to know. Resistance helps to stop the flowing current. So that's why if it is broken, current cannot flow. Although we supply with the larger force from here, it cannot flow, so it can go to the human body, and finally it can go to the ground. So I'm using here word faulty neutral wire. So if you get direct contact with the live wire or with the faulty neutral wire, then we can get a electric shock. Okay, another is a faulty electrical appliances. Okay, sometime this electrical appliances, in place of this, let us consider a electric iron have a metal body parts. Okay, electron flows from here to the iron, and iron supplies those electron to the ground, okay, through the neutral wire. But what happen, due to some kind of electrical fault, okay, this all electron will flow to the metal covering of that iron. So as soon as we touch iron, then we are going to get a electric shock. So from this we are going to get a electric shock. Not only iron, any type of electrical appliances which is made up of good conductor. Okay, if you touch that, if the electrical appliances is faulty, then definitely we are going to get a electric shock. By same thing, if anyone touch, electron will flow to the human body, and it will go to the ground. Okay, I have talked about this in the video called earthing. Okay, you can have a look after this. But let us make a idea. Okay, we need to get an idea on this topic. Now another is a lightning strike. We know that when a two cloud, okay, when collide with each other, then there will be a lightning strike from the, okay, sky. Okay, it falls to the earth. So this is the cause of electric shock. Sometimes we have heard that many people are losing their life due to the lightning strike. So this is also one cause of electric shock. Same thing, the lightning strike falls on the human body, and if the human body is in contact with the ground, if his or her leg is in contact with the ground, then any type of human body can get a electric shock. Anyone can get a electric shock. Another is a wet condition. Okay, wet condition means, what do you mean by wet? That contains a water. Okay, that is called wet. Sometime while we are taking bath in a bathroom, okay, the walls of a bathroom get wet. So in that same wall, there is a electrical earthing. Wires are flowing on that earth. Sometime we may have a power socket, electric power socket in that wall. Okay, these are the electric power socket. Okay, so as a result, if the wall is wet, okay, electric current flows on the wall. So if we touch the wall, then what happen? We are going to get electric shock. Same thing, if the condition is wet, okay, if our hand is wet, Okay, if we have a bare hand, okay, if a person have a wet hand, okay, this is a person, if his or her hand is wet in, and if this person tries to turn off the electric switch, okay, we know the electric switch is made up of insulator, okay, if this is an electric switch, if this person tries to turn off any kind of light, if his or her hand is wet, then he should be very much aware that this wetness can be a good conductor, and if he or she touches this switch, then electrical current may flow through the person and finally to the body. So this person should be very much aware that his or her hands should be dry, it should not be wet. So that's why I have used here a word dry in the place of insulator. Okay, if a wooden piece is wet, then this will not be insulated, this will be a good conductor. Okay, so this is the thing, these are the causes of electric shock. Now what are the effect of electric shock? If a person gets electric shock, then his or her hand may burn, okay, severely burn, okay, his or her body may be in unconsciousness, okay, he or she may not know anything, and even it can cause a death of a person. We have heard about this. Okay, these are the effect of electric shock. Now, what are the safety measures of electric shock? We are going to learn about this in this video. Okay, never touch a faulty electrical appliances with the bare hand. Okay, faulty electrical appliance, I am using here a word faulty. I am not saying that each and every electrical appliances is faulty. Sometimes due to some errors, due to some mistakes, okay, or due to some if we use the electrical appliances for a longer time, then what happen, it may be faulty. Okay, so we need to check those electrical appliances time and again. So that's why it helps us to make sure that we are not going to get a electric shock. Okay, and another is do not toss the live wire until sure. Okay, until and unless you are sure, do not toss a live wire. Okay, what do you mean by sure? Sure means you need to what do we call? You need to step on the insulator. You need to be sure that you can turn off this live wire connection from the meter box of your house. Okay, that is the sure thing. Okay, to be known. Now during lightning, thundering, okay, as I told you already, higher bolt of electricity flows from sky through the human body. So at that time, we need to stay away from tall trees and houses. Okay, because lightning always strike a tall trees and tall houses. Never sit on the tree. Never sit on in a tall houses which is not done earthing. Okay, those house where earthing is not done, okay, if the house is very tall, then you may have a risk of electric shock from lightning and thundering. Another one is check the grounding. Grounding means earthing. Okay, check the earthing, whether earthing is done properly in your house or not. If the earthing is done properly, then it can save your life from this type of faulty electrical appliances. If you want to know about this, you can get this video about earthing in the I button. You can get about this to know. Another one is check the electrical appliances, okay, whether it is faulty or not. If it is faulty, call the electrician, call the repairing technician to fit those electrical appliances. Another one is if anything is wrong, call the electrician, because the human life is very very precious. So after knowing this video, okay, after learning this video, you know that how electric shock occurs, okay, what are the safety measures of electric shock, and another one is how can we make ourselves safe from electric shock, and how can we make our near and dear one, okay, our family members, to convey this message, okay, to make them sure, to make them safe about electric shock. Okay, today only this much. Okay, I have only covered this much regarding electric shock, and this is the complete information. If you want anything more, then you can leave a comment in a comment section. Okay, and please leave a review about this video. How do you like? Okay, if you like this, then don't forget to share, okay, and join my channel, because this channel continuously uploads a video regarding interesting and educational content of science. We'll meet again. Okay, stay safe, Stay healthy. Bye bye.